So let's try this recording again. It didn't work last time, so we'll give it another shot. So special right triangles. There's basically two of them. All right, I'll write them down for you. Even though we've already done this lesson once before, I'll teach it again. The first one is a 45, 45, 90 triangle. And the second one, which I don't know if we'll get to today or not. I think on the lesson plans I have, we're going to do this tomorrow. All right, is a 30, 60, 90 triangle. So what kind of triangles are they? Instead of saying 45, 90, if they have a 90 degree in there, what kind of a triangle, what kind of special triangle are they? It's a right triangle, okay? It's got a right angle, so it's a right triangle. So let's do this. I'm going to, I'm just going to try to eyeball it. This may not be exact, but, oops, why did it go crooked like that? Let's try one more time. Does that look about the same length, those two lengths? Yeah. It's pretty close. We'll say they are, okay? So first of all, it's got a 90-degree angle. So what kind of a triangle? We just said it. It's a right triangle. So according to the name of this, what do you think the other two angles are in this triangle? 45 and 45, that's right, okay? Because there's the 90, okay? This one's 45. Whoops. That's a weird-looking 5. Let's try it again. 45 degrees and 45 degrees. Okay, here we go. Now, we learned something a while back. I forget what chapter it was, but we did learn something that if this is 45 and this is 45, if you have two equal angles in a triangle, there's something that's true about the opposite angles. Do you remember that at all? If I have two equal sides, or sorry, just gave it away. If I have two equal angles of a triangle, that tells me something about the opposite sides. It means they're equal to each other. That's right. If this angle right here and this angle right here are equal to each other, then the sides opposite those angles are also equal to each other. So that means this side and this side are equal. We could have done the other way. I could have said, all right, here's a triangle with two equal sides, a right triangle with two equal sides, meaning it's give me another geometry word. If you have any triangle with two equal sides, what do we call that type of triangle? Isosceles. Very good, okay? So this could be considered an isosceles right triangle. Would you agree? Right? Because two equal sides and a right angle. It's an isosceles right triangle. Well, let's pretend I didn't know these were 45. If these two sides are equal, what could have I said about these two angles? If the two sides are equal, then the opposite angles are what? Equal to each other. And since it's a right triangle, these two angles right there add up to 90 degrees. Agreed? Right? Because if this is 90, then these two have to be 90 because altogether it adds up to what? 180. Good. All right. So if these are both add up to 90 and they're both exactly the same, what do? Just cut them in half, right? Cut the 90 in half. What's half of 90? 45. So that's 45 and that's 45. Does it make sense? All right. So that's a lot of background about stuff that we've already talked about. Yeah, let's do this. I can't remember if I did this in your class or not, but I'm going to do, yeah, let's do this. Let's make this side right here equal to 1. We're just going to start off with a super easy number, okay? It's one of the easiest numbers we can deal with is a 1. So if this side right here is 1, tell me about this side right here. What would that equal? 1. It's 1, yeah, because they're both equal to each other. What I want to do now is I want to solve for C. Everybody watching? Got a lot of people, eyes are going all over the place. I know it's a little bit warm in here, but try to stay awake. Write this stuff down. Even if you wrote it down before, it wouldn't hurt writing it down again because that's going to help you remember it, okay? Listening to something, seeing something, and actually doing something, as in writing it down, is going to make you remember this stuff, okay? If you just listen, if your eyes are closed, you're dozing off, if all you do is listen, you're not going to get the whole thing. Okay, if all you're doing is just looking and staring and your mind is somewhere else, you're really not listening, you're not going to get everything. Okay, but if you write it down, you can't help but hearing it and seeing it, then you write it down, it's going to help you remember it. There's no such thing. I watched a video on it. We actually talked about that before. Okay, yep. It's all three. Everybody is an all three learner. Okay? You don't just learn auditorily. Is that a word? I don't even know. Okay, you don't just learn by auditory. You don't learn by just visual. You don't learn just by doing things. You learn by all three. Now, some might be a little bit more predominant in your, what do we call it, in the way that you prefer to things be presented, all right? But that doesn't mean that you can only learn by auditory, all right? You learn by all three. Everybody does, okay? Don't anybody tell you any different, okay? You learn by all three. You have to listen, you have to see, and you have to do. That's how we learn, okay? So let's do it. So we're watching, we're listening, and now we're going to do. The lesson that we did previous to this was the Pythagorean theorem. So let's apply the Pythagorean theorem, and I want to show you something special about the 45, 45, 90 triangle. Do you remember Pythagorean theorem? Yeah, a squared. I'll tell you what, let's do it like this if you don't mind. Whoops, let's keep the c right there. Instead of a squared plus b squared first, let's put the c squared first. Is that all right? Since that's what we're trying to solve for. So c squared is equal to what? A squared plus b squared. So what's our a and our b in this situation right here? Do we put 45s in here? No, what do we put? Right, 1 squared plus what? 1 squared. So let's do the math. Let's solve for c. It's very simple. C squared, what's 1 squared? 1 times 1. It's 1. Plus another 1 squared is 1. So c squared is equal to what? 2. Whoops, where'd that come from? There we go. Everybody see that? That's easy so far, would you agree? Everybody in here should be able to handle that. Now, here's the part that maybe it's a little bit tricky, but we've talked about this plenty of times before. So how do I get that squared away? How do I get rid of that squared? I square root it. That's right. That's the opposite of squaring something. I square root it. So if I square root this side, I have to square root the other side. Remember in algebra, whatever you do to one side, you've got to do to the other side. Now, what happens here? What happens to that square root and that squared? Give me something we say in math all the time. What do? They do what? They cancel out, okay? They cancel each other out. So c is equal to what? Is it just 2? It's the square root of 2. We've talked about this before. In your head, just remembering what I've said before, what is the square root of 2? Approximately, what is the square root of 2? We've mentioned this quite a few times. It's close, very close. No?
1.4.
It's 1.4, okay? I think it's 1.414, and then a bunch of numbers after it. I don't remember it that far. But about 1.4. Remember, the square root of 2 is completely different than just a number 2. A number 2 is this, 1, 2, all right? That's a 2. What's 1.4? Well, it's a little less than what? Halfway in between, isn't it? All right, it's 1.4, just a little less than 1.5. So the square root of 2 is not a 2, and that's what, especially like algebra students, beginning algebra students, when you first learn this kind of stuff, they just think it's just a regular 2. But why put that crazy looking thing above it? Okay? What it means is what number multiplied by itself equals 2? Well, approximately 1.4. Now, if I'm going to put the calculator out right now. Let's get the calculator on my phone. So if I go 1.4 times 1.4, I know you can't see it, but I get 1.96. Can you see that? 1.96, okay? That's close to 2, isn't it? All right, would you agree? It's not exactly 2. So is the square root of 2 exactly 1.4? No, it's, what do we say? It's, give me a good math thing. We don't say it's close to, we don't say it's, say it. I heard you say it though. You got it. You got to be quicker. You got to be quicker in here. So it's approximately 1.4. And then the further you go, the more decimals you go, the closer and closer and closer it is to 2 when you multiply those two things together. Okay, enough of that. Now, that's very important. I want you to see this. Watch. So it's the square root of 2 times this leg, isn't it? So what is the hypotenuse? It's the square root of 2 times this leg. What if it wasn't a 1? I don't know. Let's try something else. Let's not go real big. Let's just go 3. Now, we could do Pythagorean theorem. No, nobody does. It keeps on going forever and ever. I mean, I knew a student that knew pi up to 100 decimal places. I have no idea why you would want to do that. There was actually a show. Listen to this. There was actually a show a long time ago, I don't know, 90s maybe. And it was like they give you a week and you'd have to do some kind of a task, some kind of like crazy hard task. Like you had to learn how to juggle like 5 balls for like 30 seconds or something like that. Or another task would be, I don't know, they had all kinds of crazy things. But they give you a week and at the end you'd be on the show and you'd have to demonstrate what you were able to do. And one of the tasks was learning pi up to 100 decimal places. So they gave this guy or girl, I forget who it was, a week to learn pi up to 100 decimal places. Probably the most useless thing that you'll ever have to do. All right, there's absolutely no reason to know what pi is to 100 decimal places. To tell you the truth, there's no reason to know what pi is to 4 or 5 or 6 decimal places. All right, 100 is really useless. But anyway, it's kind of interesting that people know that stuff. 3.14159 is all I know, and that's it. There's no reason to know any more decimal places than that, because when you measure things, you can't get that precise anyway. What did I say? 3.14159. That's 5 decimal places. You don't have devices in ordinary everyday life that will measure things to 5 decimal places. You just don't. Okay? Even a millimeter is only how many? From a meter to a millimeter. How many decimal places is that? Nobody knows? Okay, there's 3. Listen to me. Stay on topic. Stay on topic. So even to millimeters, which is extremely small, that's only 3 decimal places, right, from a meter, right? Everybody got that? To go 5 decimal places, it's ridiculous to be able to measure it that close because you don't have devices that measure things that closely. Maybe in a science lab or something like that, they have stuff that measures things that closely, but not in everyday life. So there's no reason to memorize it that far. Why are we talking about pi? This got nothing to do with pi. Let's do this. Here we go. Let's do this one more time. I'm gonna do it. Actually, I'm gonna do it 2 more times. I'm gonna show you something. C squared equals. Now, instead of 1, what are my sides? 3 plus 3 squared. Okay. Let's do it. What's 3 squared? 9 plus what? 9. C squared equals 18. Here's something that I'm not going to require you to do, but so what is that? That's the same thing as 9 times 2. Do you agree? 18. Now watch what I'm going to do. I'm going to get the squared. I'm going to get rid of the squared, so I square root this. We've talked about this before another day. Remember how we break this down? Remember I said there's a rule in algebra that says when they're multiplied together, I could break them down into what? Whoops, what happened there? Square root of 9 times what? Square root of 2. So now, look at our answer. What's the square root of 9? Yes. Didn't you already go? I thought you asked me if you could go. Go ahead. All right, here we go. Now, I want you to see something. This is really important why I'm doing this. Because I want to show you the relationship between the hypotenuse and one of the legs. We already saw when the legs were 1, the hypotenuse was the square root of 2 times 1. Well, what if the legs are 3? Then the hypotenuse is what? The square root of 2 times what? 3. So I just write 3 square root of 2. What if we made these sides, let's say, 5? Without going through that whole Pythagorean theorem thing. Without doing that whole thing. Could you look at this and just figure out what it should be? Remember, when this was 1, what was the hypotenuse? 1 times the square root of 2, right? What if the sides were 3? Then it would be what? 3 times the square root of 2. You getting the habit? You getting the gist of this? So what if the sides were 5? What do you think this is going to be? It's going to be 5 times the square root of 2. Everybody see that? So really, what are you doing to find the hypotenuse? You're just taking the length of the side and then doing what to it? Come on, help me out. Multiplying it by the square root of 2. That's right. So as long as you know one of these sides right here, all you got to do is take that side, multiply it by the square root of 2, and that's what the hypotenuse is going to be. Okay, what if it was something real crazy? I don't want to go real super crazy, but I don't know, like 237. What if the length of that side was 237 and that was 237? Without doing any math, without doing any Pythagorean theorem, can you find what the hypotenuse is going to be? It's 237 what? Times the square root of 2. Are you getting the hang of this now? So whatever the sides are, the hypotenuse is just the side times the square root of 2. It's pretty easy, isn't it? That's what I'm trying to teach you on this first half of this special triangle lesson, okay, on a 45, 45, 90. Let's get a little bit trickier. Let's take the numbers, make it a little bit smaller, but I'm going to really change it a little bit. What if I said that this was the square root of 2? So what would this side right here be? It's a 45, 45, 90 triangle. So if this is square root of 2, what's this side down here going to be? That's also going to be the square root of 2. Agreed? Now, what we have to do, that was easy. Once you know one leg, the other leg is exactly the same thing. What about the hypotenuse, though? It is. So watch. Remember what we said? If you take the leg, which in this case is the square root of 2, what do we multiply it by to get the whole hypotenuse? A square root of 2, right? We've done that 3 times, 4 times before this. But what is the square root of 2 times the square root of 2? It's the square root of what? Which is 4. But what's the square root of 4? It's just a plain old 2. So look at this. If your sides, everybody's watching, if your sides are length square root of 2, how do you find the hypotenuse? You multiply it by the square root of 2. So even if it's a square root, I still take the square root of 2 times the square root of 2. I work it out, which is the square root of 4. Square root of 4 is 2. That's my hypotenuse right there, which is a 2. Let's do another one. You're right. There's a lot of people that have their heads down. But that's their issue. That's their problem, I guess. Here we go. Let's do another one. What if I said this? You should be able to do this in your head. What if I said the length of this side right here was the square root of 3? And you had to find the other 2 lengths. Come on, up here. Don't worry about what other people are doing. Worry about yourself.
Yes, sir.
So if this is the square root of 3, super easy. Everybody in here should be able to figure out what this one is. What's this? This is the square root of 3. Because both sides are equal to each other. Now, this is almost as easy. This is almost as easy to find the hypotenuse. If I know this is the square root of 3, what do I do to it to find the hypotenuse? I multiply it by the square root of 2. And what is the square root of 3 times the square root of 2? It's the square root of 6. That does not simplify, so you just leave it the square root of 6. See how easy that is? It's easy, isn't it? Yeah. It multiplied by the square root of 2. Right. Whatever this side is, everybody's listening, right? Except for the people that are sleeping. So this side right here and this side right here are going to always be the same on a 45, 45, 90 triangle. How do I find the hypotenuse? I take that leg and I just multiply it by the square root of 2 every single time. Now, what if we did this? I'm really going to make you think. What if I said, what if I said that this was the square root of 8? I'm trying to make a number that comes out. I think this will come out nice and easy. What if I said the length of that hypotenuse was the square root of 8? And I asked you to find this and this. I call them both x. Why did I give them the same letter? Because they're both equal to each other, right? They're both the same thing, right? So I'm not going to call one x and then one y, because they're both the same exact thing, okay? Now this time, you didn't know the leg, but you know the hypotenuse. So what do you think you're going to do if you know the hypotenuse and you got to find what the leg is? You're going to divide it by what? The square root of 2. That's right. Are you watching? Everybody awake? Look, I know it's a difficult time. It's right after lunch. It's kind of warm in here. It's not the most exciting thing you've ever heard in the world, but that's how you do it. So if they give you the hypotenuse, how do you find the leg? You would just divide by the square root of 2. Okay? So let's do that. I'm going to do the math over here. Square root of 8 divided by the square root of 2. Now, we have a rule in algebra. I know algebra is maybe not your strong point, but watch. We have a rule in algebra that says when you have a square root divided by another square root, we can do this. We can put both of these underneath the same square root. Everybody see what I just did? Instead of having 2 individual square roots, I can make one big old square root and just go 8 divided by 2. Well, what is the square root of 8 divided by 2? It's the square root of 4, right? You guys are scaring me. 8 divided by 2. It's 4, okay? And what is the square root of 4? That's a 2. So what's this? What's x equal to?
2.
That's 2. What's this x?
2.
That's 2. But then if you're looking at this, you're like, yo, Mr. Hamrick, you said earlier that this was 2, but this was 2 square root of 2. It's not. Or is it? Or is it? It is a cliffhanger. What is the square root of 8? Let's break it down. I did it over here. Instead of the square root of 18, watch. Let's figure out, let's do it down here. What's the square root of 8? So what times what is 8? Besides 8 times 1? 4 times 2, right? Do you agree? Now, what did we say we can do in algebra? If they're both underneath one big square root, I could go the square root of 4, and then I could go the square root of 2. What's the square root of 4? Girls, we're not finished. What's the square root of 4? That's a 2. And then what do I do with that? Just leave it the square root of 2. So would you agree that the square root of 8 is the exact same thing as 2 square root of 2? Yeah? So does this work? What if I took this leg and I wanted to find the hypotenuse? I just take this leg, multiply it by square root of 2, and lo and behold, there I go. That is the same thing, isn't it? So the square root of 8 is the exact same thing as 2 times the square root of 2. I know I'm kind of talking a little bit fast on this, but you can always rewind it, right? Watch the video, rewind it, and should have sent somebody with him. He's probably lost. I'm sure that's what it is. All right, let's do an example. Really, that example's no different. Yeah, let's do this. Let's do one more. Here's an example. I didn't draw this perfectly, but that's okay. If I mark it, we should be fine. Okay, here's one of the situations that we have. 45, 45, 90 triangle. This time, I'm telling you the hypotenuse, and I want you to find, I want you to find these legs. So if I call that one x, actually I think in the lesson, they call one x and they call one y. But let's just call them both x. Because they're both going to be the same thing, aren't they? So I'll just call them the same thing. You got a couple minutes. You taking notes, right? Write this down. We kind of just did this one. Kind of. Okay, but I didn't remember, instead of being a square root of 8, this is a 12. All right, I want to see how you do this. So everybody try it. So they give you the hypotenuse. I'll give you a hint. Nico, turn around, face front. I want everybody to try this on their own. They give you the hypotenuse, but you got to find the leg. So if they give you the hypotenuse, what do you do to find the leg? Do you multiply it by the square root of 2? If they give you the hypotenuse? You divide, right. If they give you the hypotenuse, We just finished doing this, okay? If they give you the hypotenuse, how do I find the leg? This time I would divide by the square root of 2. That doesn't look hard at all, does it? So what do I do? Take the hypotenuse, which is what? 12. And then what do I do to it to find the leg? Divide it by what? The square root of 2. And it looks like you're done, doesn't it? But do you remember we took a whole day, I think, with the whole class period, and we did a lesson on square roots because I didn't think that you were prepared for it from Algebra 1 because a lot of you guys were like, I'd never seen this before in my life. Remember what we do to this? At this point right now, in this class, I'd probably allow you to write that as an answer, okay? But as a math teacher, I wouldn't feel right if I just let you keep it like this. Remember I said a long time ago, some guys were sitting around. I have no idea how they came up with this, but they were sitting around. They decided we cannot have a square root in the denominator. Remember this talk? Yeah, we discussed this before. You can't have a square root in the denominator. So what you're going to do is this. You remember, Trent? What do you do?
You got to set it equal to...
Well, we're not going to set it equal. We're going to multiply it by something. Everybody watch here. We're almost done. I only got like a minute. Come on. Hang on for just a minute, okay? So I'm just going to show you how to do it. Okay? I'm not going to explain it because I don't have enough time. So watch. I'm going to multiply by the square root of 2 on the bottom and by the square root of 2 on the top. So I made it yellow for a reason. Why did I make it yellow? What's all that stuff? What's the square root of 2 divided by the square root of 2? What's anything divided by itself? What's anything? It's a 1, isn't it? Okay, that 1 is being multiplied. Does that change the value of that fraction if I multiply by a 1? Oh, the bell's ringing now. It doesn't. So watch what I'm going to do. Here we go. We're almost done. What's the square root of 2 times square root of 2? We've already done that today. So square root of 4. What's the square root of 4? It's 2. What do we do here? We write 12 square root of 2. One more thing and we're done. Watch. We're almost done. Not quite. This 2 divides into 12 how many times? 6 times. Okay? So it's 6 square root of 2. So that's what this is right there. That's the best way to write those two. It's 6 square root of 2. I don't think I gave you any homework tonight, correct? Not till what, Wednesday? Okay. So there you go. That's it. We'll do 30, 60, 90 tomorrow.